In this video, we will talk about Calf Visinse camera lens protectors. Let me present an interesting experiment on how a manufacturer-defined function can be further developed or completely rethought by the user. I am not claiming that it will be better than the factory solution. I am just trying to design and build a prototype from my own perspective that will eventually be usable. The camera lens protectors are separate silicone rubber caps that can be removed and replaced individually. The disadvantage of this process is that in some cases there is nowhere to put the removed protective cap. This is what the cover looks like under the microscope when taken out of the pocket. Typically, if I don't have a pocket, I put it down somewhere and forget about it. I've had to look for it after I've finished shooting. In short, it's quite cumbersome to use. Another important thing to note is that lint and dust can stick to the silicone. Since the cap geometry follows the curve of the lens, there's a good chance that dirt stuck to the cap can scratch the lens surface. I want to avoid this and create a completely new concept. In the first version, I developed a rack pinion mechanical solution where the two protective caps move symmetrically. The bigger challenge was to properly secure the moving parts in their end positions. I needed some kind of securing solution that would withstand wear and tear. I quickly discarded this idea due to its complexity, because after assembling the printed parts, it became obvious to me that it wouldn't work. This version failed to provide dust protection for the lenses. The second version is a completely different approach, with a hinged pivot point that can be folded down 180 degrees. This is much better in every way, because the dust seal has been solved on the outer ring of the lens. I used magnets to secure the cover when it was closed, but unfortunately I didn't think about the need to secure the cover when it was open as well. So I finally made the third version, which now meets all the criteria. A magnet holds the cover in place when open. It works so great, I'm completely satisfied with the result. The haptic feedback and clicking sound of the magnets is very satisfying. The printed components, 4 magnets, 2 screws, and 3M adhesive weighed 69 grams. This is added to the 300 grams of the camera. The silicones are 20 grams, so the weight has increased by about 50 grams, which I think is completely acceptable considering the benefits. Overall, I really enjoyed making this project. Let me know what you think in the comments.